Hey there, fourth grade. I want to spend another day talking about multi-step operation problems today, and I want to talk today about using visuals. So here's what you can do. If you look at your WeDo from yesterday, we're going to do the same one. If you have space on that page to use another strategy, like if you have space at the bottom to show it another way, you can just use that page again. If you need to turn the page and make a new page with this title, please do that, and unpause when you are ready to go. So yesterday we worked on multi-step operation problems just using the math. And look at this one. I mean, this looks scary. When you look back at this problem from yesterday, even if you understood it as we went, this sure looks like a lot of math. And it just may be that keeping all this stuff organized is either difficult for you or annoying for you or just, causes a lot of confusion that you don't want. So I'm going to erase and start over here. And I want to just acknowledge that first, these questions are tough. These multi-step operation problems are tough because you've got to figure out, what operations do I need? What order do I need to do them in? And things like that. And then it can just be pretty tough to do. So if just crunching a ton of numbers like this doesn't always work for you, or even if it does, I just want to remind you, you can kind of think through math sometimes and use some visuals to help you in ways, kind of help you organize your thinking in ways that make the problem easier to do. So I want to just kind of think through this same problem yesterday, and I want to just organize it differently rather than just simply crunching numbers. I just want to, sometimes it can help me out to just kind of draw what I've got. So here I say, Jason loves tennis. He has 25 cans of tennis balls, and each can of tennis balls has 3 balls in it. So off the bat, if I want to just visualize that, even if I just do it once and say, okay, he's got these cans of tennis balls, and each one has 3 tennis balls in it. Say, okay. So even if I don't want to go much farther than that, I can say, okay, this is kind of like what I'm starting with. Right? I've got this, and maybe I even want to write times 25 next to it. I could draw that 25 times. If it were like 6 cans of tennis balls, I would probably draw all 6. With 25, I'm probably not going to, but no problem if you would like to. So here we go. So I just kind of like start thinking through what I've got, right? So he has 25 cans of tennis balls. I kind of dealt with that. Each can has 3 tennis balls in it. Okay. Kind of dealt with that. And even right off the bat, this may be easier for you to look at and say, okay, I can see how many tennis balls he has more than this. Or even if you didn't know what operation to do and you thought maybe that was division or something, just kind of drawing what you have can really help. Maybe even say, he has like 25 of these. And it just helps me think what I've got. Okay, so I've kind of dealt with the first part a little bit. Jason wants to play 9 tennis matches this season, so he's going to play 9 matches. So I could draw a little tennis court if I wanted. Might just make a space for each one. Match 1, match 2, match 3, 4, 5, 6, 7, 8, 9. Okay, so now I've kind of got like a calendar here. Ooh, that would have been a cool way to do it. I might do that. I'm going to make a calendar. Sorry to make you watch me do this again, but now that I thought it's a cool idea. There's 9 matches to play. I might do, you see them draw like these, people like check off their boxes after the days go by or something. I'm doing that. My calendar. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So he's got these 9 tennis matches coming up on his calendar. And, well, let's see. How many can he bring? He wants to bring an equal number of balls to each match. So he's got 25 of these cans and 9 matches. So let's see. If I put 1 can in each box, 1 can. That's 9 of the cans. 1 can, 1 can, 1 can, 1 can. Let's see, can he do that again? Can he bring a second one to each? That'd be another 9. That's 18. So I'm going to do 2 cans. 2, 2, 2, 2, 2, 2, 2, 2. So now I'm bringing 2 cans of the tennis balls to each match. So let's see. That is, how many have I used? That's 18. So I've used 18 of the cans, and that leaves me with 7 left. So I can't take a third can to each match, right? So now I'm going to have to open the cans and put them in there. So let's see. So he's got 7 cans, 3 in each can, so that seems like a total of 21 more to me. All right, 3, 6, 9, 12. Count by 3s up till 7 times. So I can put 21 more of the tennis balls. So here we go. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I can't go again, right? So I've used 18 up, so I'm down to like 3 left. And if he wants to bring the same number to each match, looks like we can't use these 3. So I guess he's just going to have to keep these 3. And so let's see, 2 cans, each can has 3, so that's 1, 2, 3, 4, 6 from the cans, plus 2 more. Looks like he can bring 8 to each match. Yay. And have 3 left over. Remember, you've got to, when you talk about your remainders, you've got to mention them. Keep the 3 that are left. Or I guess you could say he could bring a 9th one to 3 of the matches. That would probably be fine too. So I don't know. So maybe thinking through it like that, you notice I didn't really crunch a lot of numbers there. I just kind of like worked it out with drawings and organization. That might be easier for you. It might just be more fun for you. You know, if taking a problem like this and just crunching the numbers is boring or not very fun. Sometimes I just think it's interesting to communicate my math with visuals and with drawings. And so I just want to give you ideas for how you can too. There's not necessarily a certain way, right? I just kind of went with the information I had and did something that makes sense. It's not like I said, okay, step 1, you always do this. Okay, step 2, you always do this. Because these kind of problems don't work that way. It depends on the operation, depends on the size of the numbers, depends on a lot of things. So I just kind of started and went with what I knew and ended up with this. And I kind of like it. All right, open your math notebook. Let's do one together. Again, if you have yesterday's and you just want to look back at yesterday's, you can. So here it is. So we did this deal with the Braves Stadium and the Hawks Arena. And again, a lot of math, a lot of numbers. And again, if you just look at the problem, sometimes these problems can be intimidating because you're like, oh gosh, I can tell I need to do more than one operation. This big number, something else. Multiplicative comparison, twice as many. Oh boy. There's a lot going on here. So sometimes before I even try to figure out what to do, I just sort of try to visualize what I know. And so here's what I'll do. So I'm going to here's what I know. Okay, Atlanta Braves Stadium can hold 41,119 people. I don't really know how to draw a stadium, do you? Kind of round. I guess they're kind of round. I'm going to draw like... I can't draw. If you can draw, it's more fun. That looks like a bowl, not a stadium. But it's going to be my stadium now because I already drew it. And the way you can tell it's a stadium is I'm going to put a sign on the top that says Braves. Now it looks like a toilet. Oh well. Okay, so now I have my Braves Stadium here. And the Braves Stadium holds 41,119 people. Okay, I don't know what I'm going to do with that, but I know I have it. I already have this information. The Hawks Arena, I'm going to play it safe here and just draw a rectangle so I don't end up with another disastrous drawing. The Atlanta Hawks Arena, that's the basketball team if you don't know, I like them. Has a Hawk sign on top, obviously. Can hold 21,613 people. Okay, I didn't really do anything with that. I just drew it because I knew it. Ooh, that rhymed. Hey, that might be a thing. That might be a new saying. Drew it because I knew it. All right, so I got that I just kind of drew what I knew. There's a stadium in Texas that can hold twice as many people as both of these stadiums combined. I'm going to read that again. There's a stadium in Texas that can hold twice as many people as both these stadiums combined. So what I'm hearing is all these people, the stadium in Texas is like 2 of them, right? So it's like that, but it's like that again. So it's like I almost take this. I have a copy feature on here. It's kind of cheating. It's like I already have like, you know, this. It's almost like I have this, the stadium in Texas, which I could draw to look like a stadium. Should we do another stadium, or is that too likely to be a disaster? It's going to be a disaster. Let's just do it this way. So Texas, I'm going to erase the problem. I got to move the problem. It's in the way. Delete. So now when we're in Texas here, of course there has to be a sign up that says Texas. And in Texas here, I've got this stadium that holds all this twice, another 21,613 and another 41,119. And now, again, if just seeing a bunch of numbers stresses you out or confuses you and you're like, oh, I don't know what to do, what operations to pick, do I divide, what do I do? Now when I look at this, I'm like, okay, this is kind of straightforward. I am going to have to crunch some numbers. But if I want to know how many people this Texas stadium holds, there it is. I'm just going to add this and this and this and this, which is not that bad. It's just addition. You know, 41,119 plus 21,613 plus 21,613 again plus 41,119. And now I just have to add all those up. Not so bad. 18, 19, 20, 21. 2, 23, 24, 3, 4, 5, 6, 7, and 7 is 14. 1, 2, 3, 4, 5, and 6 is 12. 125,464 people, and it doesn't even feel like I did that much math. So again, this is a second strategy. If you can just look at a problem like this and just know, okay, I need this operation from here, and I need this operation from here, and I know what order to do them in, and I just feel confident doing it, and you don't mind doing it, go for it. But sometimes drawing and showing your thinking, A, can be more fun, and B, can sometimes be easier or help you organize what's going on. And so I like you to know that it's a tool in your toolbox, and I hope it's one you'll try from time to time. Frankly, this is why I always have you do illustrating math, is so that you'll try things like this, so you get used to showing what you know to someone who maybe doesn't understand just a bunch of crunch numbers, and that you can kind of communicate with pictures or drawings or representation. If you can't draw, look, I drew a toilet on this thing. You didn't have to be able to draw well, just enough to organize your stuff so that somebody could see what's going on. Okay? So that's the second strategy. Hope it helps. Can't wait to see you tomorrow.